Here we go. I'm going to start your homework with you guys today, and this is Chapter 4A worksheet. This is all about complex numbers. So number 5 is what we're going to begin with. It says to go ahead and to simplify expression each number by using the imaginary number. So if I'm simplifying this, the square root of -8. My question to you is, what do you notice? It's a square root, it's an even root, so therefore I'm going to have an imaginary number. So I immediately put -1 times 8. And then I ask myself, well, what does -1 represent? -1 is going to be I squared. Is 8 a perfect square? No. What factors of 8 do I have? I have 4 times 2. And what is the square root of I squared? That comes out as 9. What's the square root of 4? That comes out as 2. Those are attachment multiplications. So that's 2i square root of 2. And that's your answer. That is how you're going to do problems 1 through 6. Keep in mind, number 6 is square root of -48. If you're not sure how to do that, we just covered that yesterday in the video. Okay, number 12. This is to simplify each expression. Well, if you look at number 12, this is going to be a multiplication problem. Why is it multiplication? Because that lovely little 2 right there, means that I actually have how many of these? Not 1, but yes, 2, folks. That right there is why it's multiplication. So what am I going to do? I'm going to FOIL. -1 times -1 is 1. -1 times 3 is -3i. -1 times 3i is going to be -3i. 3i times 3i is going to be plus 9i squared. How many of you are thrown off right now that I wrote plus negative? Just for those of you who might be thrown off, that's the same thing as saying minus there, just so that you're with me. Do I have any like terms? Sure do. -3i is going to be -6i plus 9i squared. What's the important thing to remember? I squared is -1. So here I'm going to have -1 minus 6i plus 9 times -1. And that's going to give me 1 minus 6i minus 9. Like terms, -8 minus 6i. Ooh, 14 looks a little bit ugly. I have square roots in there. The square roots have negative numbers underneath them. So let's talk about that then. That's going to actually give me -1 times 4. This over here is going to give me -1 times 9. Well, what does the -1 mean underneath a square root? Well, that's I squared. So that's I squared times 4. This one over here is going to be I squared times 9. So what is the square root of I squared? I. What's the square root of 4? 2. What's the square root of I squared? I. What's the square root of 9? 3. So now I actually have is 2 plus 2i times -1 plus 3i. Totally different problem, but now I know how to do it. Because you can clearly tell it's just going to be a multiplication FOILing problem. So in and out first gives me, first is 2 times -1 gives me -2 plus 6i minus 2i and then plus 6i squared. Combining like terms, that's going to give me 4i plus 6i squared. What's I squared, folks? -1. So that's -2 plus 4i plus 6 times -1. And that's going to give me -6 to give me a -8 plus 4i. Next set of instructions, if you turn it over, write each quotient as a complex number. As a complex number, that's a plus bi, folks. Well, what am I dividing by? Is it a monomial, meaning 1 term, or is it a binomial, meaning 2 terms? Well, this is going to be a binomial. So if it's a binomial, I need to multiply by a value of 1. But most importantly, I need the conjugate of the denominator. Well, what's the conjugate? That means the real number stays. That's going to be 4. And that means the imaginary number, which is -3i, changes to plus 3i. So this 1 turns into 4 plus 3i over 4 plus 3i. Putting parentheses around every single thing. The top I FOIL. 3 times 4 gives me 12. 3 times 3 gives me 9. Minus 2i times 4 is going to give me minus 8i. Minus 2i times 3i is going to give me minus 6i squared. All over. Now these are conjugates, remember. So when you're multiplying conjugates together, I only have to do what? First and last, because inner and outer will always cancel. So 4 times 4 gives me 16 minus 3i times 3i.
Good afternoon, staff.
Apologize for that. Last, I do negative 3i times 3i to give me minus 9i squared. Now, again, what should we remember here? If I combine my terms on top, I'm going to have 9i minus 8i to give me 1i. And on the bottom, I need to now remember that I squared is actually equal to 1. So every place I see an I squared, I'm going to put in there negative 1. So I have 12 plus I minus 6 times negative 1 over 16 minus 9 times negative 1. So this minus times the negative is going to make me a positive 6. This is going to make this a positive 9. So what is 12 plus 6? 18 plus I over 16 plus 9 is going to give me 25. I accept this, or a plus bi form to give you 18 over 25 plus I over 25. In the last problem, set of instructions says to solve each equation, check your answer. So if I'm solving this equation, what am I going to do here? I'm going to isolate this x squared. So if I'm isolating that, what am I going to do with that 5? I'm going to subtract 5 from both sides. That gives me 2x squared is equal to negative 36. Now what? Divide by 2, and I have x squared is equal to negative 18. Well, what would you do? Well, you would take the square root of both sides. If I take the square root of both sides, that cancels that out with x is equal to plus or minus. In this case, I'm going to have negative 1 times 18. Well, that's going to be, what's negative 1 equal to? I squared times 9 times 2. This comes out as an I. This comes out as a 3 to give me x is equal to plus or minus 3i square root of 2. And if you're looking at 25 on your paper, 25 tells you that you have something that looks like this. Hold on a second, actually. Now, all they want to know here is what is letter A. Letter A, ordered pair, is going to be the real axis. It's going to be 1, 2 units. And then from there, I'm going up 1, 2, 3 units on the imaginary to give you 2 plus 3. That's all it's asking for. So I've started you all on your homework completely, so now all you have to do is finish up. If you need any help, please ask.